Perfect. Alex, you can start now.
Okay, so my name is Alex Fleischer. I've been involved playing, developing with Seaplex for 20 years, and 15 years ago, I joined iLog, and I really fell in love with OPL, and I will try to explain why and teach you a few tricks. By the way, my presentation and heads are not that far because we have to deal with huge models. And when you have a huge Simplex model and you want to solve, you could improve the settings and then it can give you some improvements, but you can also improve the model itself. And with OPL, we'll see that it's much easier to improve the model than with any other API. So who am I? I address that. I'm doing a lot of cycling, as you can see on the left. And OPL, what and why, making optimization simple, how to with OPL, some examples, some tips and tricks, some fun, because we can provide some fun too. We can save lives with OPL and Simplex. We can save money, of course. Some questions. And in a nutshell, all this material is after answering something like 5,000 questions from customers years after years in our forums, and I gathered some answers in order to help other customers. So here it's a screenshot, a picture I took last year at Think conference where I had 2 talks. And on the right, you can see the different programming languages I have been involved with as a user for 40 years. So I started with BASIC. I fell in love with OPL. Well, I met OPL in '99, and it took me 6 years to be convinced and to become OPLolic. And got certified a few months ago. So this is a famous example I used in the past in order to explain what optimization is. On the left, you have that in English. It's translated into 23 languages, so it was quite popular. In the middle, in OPL, in the right, in Python. We have many different APIs, and you can see that with OPL, it's very easy to understand. So it's very easy to write too. So many good properties. I wrote an article 5 years ago, which was quite popular and led to more than 5,000 views. So why would you use OPL? Because it's much easier, because even experts say that they model 4 times faster than when they use any other API. A business user told me that it was like a running documentation. So even a user sometimes can have a look at an OPL model and understand what the Simplex model does. So it's a good, nice property. It's easy to share if you need help, if you need to explain something to someone else. It's easy to get help. So I have a link here, but you see many good reasons why using OPL is a good idea. And you can see that you can call Simplex from OPL, but also from C++, we have maybe 20 different APIs. So here you have some statistics about the different APIs our users use. So you can see that OPL is about 32%, and the second one is Python. Python is a very good API too, but OPL is still my favorite. And as Sumit said, you can call OPL, you can use OPL from the IDE, from Watson Studio, from Cloud Pak for Data, in Watson Machine Learning, in Decision Optimization Center, on top of Planning Analytics, and in Python through our DoOPL framework. So it's very easy. You can call OPL from many different places. And in OPL, you can both use linear programming and constant programming. So in order to teach OPL to students, I used some examples out of the bus example. So making decision optimization simple. It's very easy to learn. So first example, very basic. You have 12 And for that, you have 46 buses and 36 buses. So you can write the OPL model like that, and you have everything. It's a model, and you will run it in the IDE, and you will get the answers. 2 buses, 46. 4 buses, 6 buses, 46. And you can see the integer decision variable, nbBus40, nbBus30. You have an objective, minimize cost. So you have the formula of the cost, and you have one constraint. You have to bring 300 kids to the zoo. You can then move up and add some abstraction. You can have a dedicated data file in order to be able to solve many different problems. So here you can see the same model, but instead of the values, I use ... which means the data will be in another file. So here it's in a data file, nbkids equals 300 and so on, but it can also be fed from an Excel spreadsheet or from anywhere. So this adds some abstraction. Even further, you can use arrays and sets in order to have different kinds of buses, more than 2 kinds and so on. So here you have some sets. So instead of having 40 and 30, you have a set of int, so the seats. And then you have an array, the cost bus, so the cost of a bus of a given size. And again, you have exactly the same model. I want to minimize the cost to bring the kids to the zoo. Even further, you can use tuple sets, so like classes struct in C and record in Pascal. So you have your different buses with different properties. So a bus has a size, nb seats, and a cost, and then you write again the same model. You can add some checks, like you want to be sure that all the seats the NB seats are more than 0. You want to check that all the costs are 0. You can check all this. So you can add some asserts into your model. And in order to use constraint programming, even if you don't master constraint programming already, it's very easy. You just add using CP at the top of the model. And then instead of relying on Seaplex linear programming, you will use constraint programming. So very easy. So for all the classical Seaplex users, I really recommend to have a look at constraint programming. It's very easy to learn, and you will be able to tackle some big models that you would not be able to tackle with mathematical programming only. And what many people, even very experienced Seaplex users, do not know, unfortunately, is that within OPL and with all Seaplex APIs, you can also directly use logical constraints, not only linear constraints. So, for example, if you want to say that if nbBus40 is more than 3, then nbBus30 is more than 7, you can directly write nbBus more than 3 implies nbBus30 more than 7. You don't need difficult big M's. You don't need to call an expert. You just need to write this. And recently, we added a new feature, which is very convenient. So we can add multi-objectives. So suppose you want to first minimize cost, and then second objective, minimize CO2 emission. You just write minimize static lex, first cost, and then CO2 emission. Very nice properties, again, because it's very easy to read, but it will also help Seaplex solve much faster, because this lexicographic order is much easier to solve than doing the first one times 1 million plus the second one. Within Seaplex, within the IDE, if the problem is infeasible, OPL Seaplex will provide some conflicts and some relaxation. So you will directly get this kind of output in the IDE. So it will help debug, but it can also help you understand what kind of resources you miss. From the ID through ILO OPL exec. So it's a very nice instruction to call anything outside of OPL. And by calling Python, you can have very nice, any kind of graphical you need. So upper left. So for simulation, you can do that and it will display this kind of curve. So it will be, this is the cost according to the number of kids you want to bring to the zoo. On the right, you have a display of OPL within Watson Studio. So very convenient if you want to add optimization on top of some machine learning models within Watson Studio. And within the ID, you can easily, through right-click, call Seaplex on your machine, on a server, on Seaplex Cloud, or on Watson Machine Learning. So very easy. You right-click and you have all those options. OPL models can be called from Java, .NET, and C++. So many people do not know that, but once you have your model in OPL, you can easily call that model from those programming languages and see all the OPL objects like constraints and so on as native objects. Very convenient. And you can also call OPL from Python through a package that you can download, doOPL. Very convenient too. I gathered many answers in how to with OPL, and it was very popular, nearly 5,000 views. So if you have time and you need some tricks, you can go there. Some tricks I gave there are how to change some data and solve again, how to change a 2D array and solve again. And what is very nice is sometimes I get questions from customers, and I see from the questions that they are relying on the previous post on those tricks I gave a few years ago. Or some tricks to start with traveling salesman problem with many different techniques, constraint programming, linear programming, MTZ, remove circuits. So good ideas and bad ideas. I let you have a look at that. I also, in order to help you, wrote the models that were not in the product from the very nice book by H.P. Williams, Model Building in Mathematical Programming. So some were missing, and I wrote them, and this helped some customers. And recently, I added my latest post a few months ago, tips and tricks in OPL. So even after all my posts, there were still some questions, and I added that post on top, like how to turn a CSV into a DAT file, how to export the result to a JSON file. So many questions I got here and there, and I gathered them in that post. As I said, OPL Seaplex is very good at tackling models for work, but you can also have some fun with OPL. So every month, for more than 20 years, IBM Research is posting every month a challenge, a kind of puzzle. And if you solve it, you have your name there. And I'm proud to be among the best, let's say, the good solvers. And for that, I added one more constraint, which is I have to use OPL, and I have to use either Seaplex linear programming or Seaplex constraint programming. And with that, I managed to be quite successful at that puzzle. I invite you to have a look at this very nice puzzle. It's a bit addictive, so be careful. For example, my favorite challenge was you have 11 coins, 4 are fake, 2 are fake, sorry, they are lighter than the other ones. And in 4 scales, you have 4 scales, and with the 4 scales, you have to decide which coins are fake. And you have to tell me right now, for example, the first scale will be A and then B, and then the second scale will be C and D. You cannot wait for the first result to use the second scale. I love that puzzle because it's very simple. and I was second, and it was in May 2018. I was second, but the revenge came the year after that. I was first. But it was the only time I was first for that challenge. I really encourage you to have a look at this. It's addictive, as I told you. Seaplex with OPL can also save lives. So one of my favorite customers in France, what is he doing? What he's doing is rebalancing stretcher bearers in real time within nearly 15 French hospitals. So according to the demand of transport for sick people within a hospital, Seaplex and an OPL model will in real time say, okay, stretcher bearer A, you have to move from this room to that room with that guy in order to save people. They are very successful and they can save a lot of money in hospitals. So 1 hour, the surgery room, they can close 1 hour before on average, and the stretcher bearers, they used to walk 18 kilometers a day every day, and now they walk only 12 kilometers a day. Very good ROIs because they're saving lives. A small company in France, Biosco, they do supply chain for agriculture, and in order to do that, and in order to have a good time to market and to be able to deliver what the ideas they got, they use Seaplex and OPL in the cloud. And other customers, so bigger customers, Coca-Cola, they are using OPL and Seaplex. Monsanto, there was an article, they are also relying on Seaplex and OPL. And we have a very active forum in the IBM community forum. So it moved last month, but it's already very active in its new place. So this is the very short URL to remember. And if there are some questions, I can answer.
Okay. All right. So let me hand it over to Ed. All right, Ed, you are now the speaker and presenter.
Thanks, Amit. Can you see my screen, or do I need to do something else?
You have to also say share screen. So you are the presenter, but you'll have to
share my screen. There we go.
Yes. Yep. Now I can see.
Okay, let's go to, let's try full screen mode, see how that works. Okay, so welcome to the first Seaplex office hours. I'm going to talk about tuning fundamentals. Now, 15 minutes is not a lot of time for such a complicated algorithm, but we can still do a lot. We can, do a very minimal description of the algorithm, but link the algorithm to the node log Seaplex generates. And even without being familiar with the algorithm, we can make significant progress. And then I'll touch briefly on some new Seaplex features and external add-ons that also can facilitate performance, sometimes without any performance. So the problem we're going to solve, we're going to view our mixed integer program as a minimization of a linear or quadratic function, subject to linear constraints, bounds on the variables, and then integer restrictions on some or all of the variables. I've listed the constraints as equalities, but any mix of equalities and inequalities is acceptable. So here is our branch and bound algorithm, and we're going to do sort of a Cliff Notes summary here. And we'll see that that's sort of all we actually need to do to get started. So this is a tree search algorithm. and each node in the tree has a linear programming relaxation that we need to solve. And as we generate these nodes by branching on the variables, what's going to happen is we're going to find some integer solutions that are going to establish an upper bound on the best possible solution. You know, we've got this solution in hand, so the optimal solution is at least that good. And then at any point in time, we have a set of nodes that have yet to be explored. And those nodes, as they change, establish a lower bound on the best possible integer solution objective value we could have. And as we progress, these upper bounds and lower bounds dynamically move towards each other. So we've optimized the model when the gap between them drops to 0. And we also have the option of stopping when the gap gets below some certain percentage that we view as good enough for the system being modeled. So if we think about this, we can ask ourselves, well, how does the algorithm make progress or not make progress? And it really boils down to three things: how well the upper bound moves, how well the lower bound moves, and how quickly we can generate and process these nodes. The node log that Seaplex generates has a lot of information about those three progress metrics. So here we see a typical node log, and over here in column 6 is a measure of lower bound progress. And then, but connected to that are columns 2 and 3 in the sense that the size of the active node list gives you some idea of lower bound progress. And the number of nodes in the objective column that are either infeasible or cut off, where cut off refers to the upper bound. The more you have that are cut off or infeasible, that means the more nodes you are pruning, and that tends to manifest itself as progress in the lower bound. So you look at those 3 columns to assess lower bound progress. You look at columns 4 and 5 to assess upper bound progress. And then you look at 7 to assess node throughput progress. So in this example here, what we're seeing is progress in the lower bound. Here in column 6, it's moving, but progress in the upper bound is not moving. And in terms of this integer infeasibility column, that's telling you how many integrality violations you have in the node LP solutions. So it's not a direct piece of information for the upper bound, but it gives you some idea as to how close these node LP solutions are to integrality. And then in terms of node throughput, we see in this case the cumulative number of simplex iterations across all the node LP solves. So if we drop down to the last line, we take this 57,000 number and divide into it 1,000 nodes processed. So what we see is that we're averaging about 7 iterations per node, which is an indication of good node throughput. By contrast, if we had seen hundreds or thousands of iterations per node, that would be a sign that node was a problem. Excuse me. And move on to a different node log for a different problem. And what we see here is in column 5, we're making good progress in the best integer, but the best node value is not progressing at all. So the point is that the strategies that you would use are going to vary for these two models. What works for a model where you're making progress, you're lacking progress in the best node is going to be different from what works for a model where the lack of progress is in the best integer. Okay, so let's sort of build up a list of what to do when your problem is not solving as quickly as possible. So first, before you start to think about tuning, make sure you have the latest solver version. Each new version has more capabilities than the last and has a tendency to thin the herd of the hard models out there. But if that doesn't do it, consult the node log like in the previous two slides and determine where is the lack of progress coming from. We have these three categories: best integer, best node, and node throughput, or sometimes it's some mixture of the three. And a deeper dive than what we'll do today appears in the link I provided here, where there's a full 50-minute presentation on this notion of mining the node log to get information. So again, you use what you've done in this previous step to decide which parameters to set. Again, parameters that help the best node often are at the expense of progress in the best integer or vice versa. Beyond that, the list goes on, even though we won't dive into any of the rest of these topics. Excuse me. But making good use of various solver tools that basically implement sort of more advanced algorithms is one thing. You can tighten the existing formulation, and I'm giving you a link to a tech note, which in turn links to even more detailed papers on this subject, which is, you know, quite elaborate, but at the same time, there are some things you can do sort of very early on to get started quickly. And then beyond that, there are other advanced algorithms that Seaplex doesn't offer directly. Sometimes those are the way to solve a problem. But, you know, they require using the solver API, sort of implementing something yourself. And then lastly, model formulation. Or model reformulation, where you sort of change the model into something equivalent that solves better. So that was something Alex sort of, I think, pointed out about Opal, that, you know, it's well suited for, you know, making changes to the model formulation. So basically what we have in slides is we have sort of a ladder from simpler tactics to more complex tactics to try to address performance issues. So you work your way up the ladder. You start with the easiest stuff, and then you move on to get to the one that you need to actually solve things. Now, today the subject is tuning solver parameters, and as the solvers like Seaplex have become more sophisticated, in some ways, it's harder to get good results with non-default parameter settings. But there are still plenty of models where that does happen. And also what I find is, as Seaplex becomes more sophisticated, it's basically doing more calculation by default. And sometimes you actually want to reduce the amount of calculation it does, and you can save time that way. And we'll talk about that a bit more later. Seaplex also has an automatic tuning tool that where you basically give the model to Seaplex and say to it to go run some things, and it will come back with some suggested parameter settings. And again, though, when you make these decisions, the key thing is to focus on the three pillars that affect performance: the best integer, the best bound, and the node throughput. Your parameters accordingly based on which one is identified from the node log as the trouble spot. And here we have a table that sort of breaks this down in more detail. So in the first column here, we have our three progress metrics: node throughput, best integer progress, and best node progress. Then in our second column, we have how to recognize in the node log that there's an issue. So for example, with node throughput, you look at the average iteration count per node. In the other two, you look at lack of change in either the best integer or the best node value. And in the best node value case, also increasing size of the active node list or the list of unexplored nodes comes into play. And rather than sort of go into detail on the list of suggested parameter settings, I'm going to illustrate subsequently with an example. So the point in this third column is just that basically there are different tactics for each progress metric. So you use different parameter settings, and the slides will be available so you can work your way through the detail. Broadly speaking, when you increase the intensity parameter setting, what you're basically telling Seaplex to do is to do more computations, to get more information about the problem so you can make more refined decisions. So what that means is you set up a trade-off. The additional time spent has to be worth it. For example, if you increase the intensity of cuts and heuristics, you better get a reduction in node count to compensate for that additional calculation. Likewise, if you threads at a MIP model, you're going to improve your node throughput, but you're going to pay a cost that you have more threads to synchronize. So there's a trade-off there, and you have to balance those out. But reducing the intensity of default settings can also help, because as we've added more functionality, sometimes functionality can be effective but redundant. A classic and common example I see with this involves heuristics to find good solutions that we apply at the nodes. I see plenty of models where they are finding solutions, but you don't need them because branching can find the same solutions, and we don't need to spend that extra time. Likewise, disabling cuts may give up something as far as the tightness of the model that Seaplex solves, but the increased node throughput may improve the chances for heuristics and branching to be effective, and you still may get faster results. So let's illustrate with an example where we sort of go through this process. So this is what's called a hard MIP-lib model, which means that it's been solved to optimality in some way, but not by any solver with default settings within an hour. So the problem is pretty modest in size and even smaller after Seaplex's pre-solve finishes. And if we look at the default node log, we see a lot of opportunities for improvement. So first of all, going down to the bottom, we see that it took almost 2.5 hours to solve this model of modest size, despite generating less than 1,000 nodes. And if we start looking at the node log, we can get some ideas as to where the lack of progress is coming from. So first of all, the initial root node solve was solved with the barrier method in less than a minute. So what we see here is this low iteration count and good runtime, even though we have to solve that initial root problem from scratch. But then we go into our cut and heuristic loop during the root node, and we now have advanced basis information. So we use the dual simplex method by default, and we're seeing some really big iteration counts. And what we see is that we take almost 40 minutes to process the root node. And we see good progress in the best integer or upper bound value here. The heuristics at the root are doing well, but it looks like, as with the cuts, they may be time consuming because a lot of heuristics solve LPs and are using the dual simplex method to do that. And then we also see that the cuts don't really yield a big improvement in the best bound value, despite the amount of time they take. So there are questions about heuristics, there are questions about cuts, and there are questions about node throughput in this model. So based on the biggest thing to speed this thing up was just to solve all the node LPs by using the barrier method, which means in Seaplex terminology, set the sub-algorithm parameter to 4. Since there was some question about effectiveness of cuts, I tried turning them off. That turned out to basically be a wash. But if I then also turned off heuristics, I did get an additional improvement of about another 5 or 6 minutes. So what was going on is the heuristics were effective, but branch was just as effective. Just by looking at the node log, we got a speed by a factor of over 4 by some relatively simple parameter tuning. Let me move towards wrapping up here. And here are a couple success stories, open MIPLIB models. Now this only works for certain types of problems. So, you know, obviously there are plenty of other MIPLIB models where this doesn't help, but you can try it and it's pretty easy to see if it's not going to help. And then another external tool, which I think we'll probably go into in a future one of these office hours sessions, is the optimization direct heuristic. It also is shown to be very effective at finding additional feasible solutions. And I'm sort of giving a list of success stories on the MIPLIB set with this tool. And this really only scratches the surface of how well it did on some of those hard models in terms of finding better solutions than the best ones known. And then sometimes you can use Seaplex sort of in conjunction with the optimization direct heuristic, in the sense on this one model, we ran Seaplex for a while, then passed the solution Seaplex found to the optimization direct heuristic and ran it. And that was more effective than running either of the two tools separately standalone. So that there are lots of synergies there. And if you go to the Optimization Direct website, you can get more information about some of the successes on the MIPLIB models. So that sort of is the end of the presentation. Many of your problems are just going to solve easily enough with defaults, but we saw tuning parameters by looking at the node logs to figure out where the lack of progress is coming from can be enough to improve performance. And then moving along up the performance improvement ladder, there are some deeper dives into parameter tuning that you can do. There are these other tools. You can tighten the existing formulation. You can use Seaplex's APIs to implement alternate algorithms, or you can actually consider reformulating the MIP. So there's this whole ladder of things to do, but you want to start with the ones. And I'll finish up with the last slide just has a few links for deeper dives. Let me get out here.
You can,
and
yeah, if you want, you can leave your screen on the WebEx. But with that, first of all, thank you, Ed, and thank you, Alex, for covering those two topics. There are a lot of questions, so let me start reading some of those. Some of those are getting answered in the box itself. But before I start going into the Q&A, I just want to make two quick comments. One is, since there are a lot of questions we've been seeing in this session and in the previous session, so we are okay to go past the hour. So if people want to stay and ask questions, be available even after the scheduled time. And second thing is, once we close, you will get a feedback survey. And in that, I have a question where I'm asking you guys, if you have any specific topic to recommend for the next calls, feel free to use that opportunity or send us an email to let us know what topic would you like to cover in some of the future sessions. So for example, Ed briefly covered vendors decomposition. So if that is of interest, we can have a session on that. And also I'm seeing a lot of questions on constraint programming. And that is something in my mind to bring out as a topic in one of the future sessions. So feel free to ask more such suggestions if you have any specific topic to cover. Okay.
I actually have a operational question. Are the slides going to be available somewhere to the people who attended?
Yes, that's a good question. And I know some people have also asked me where will I make the recording available. So let's figure out the logistics. But what I'm thinking initially is I will create a box folder and I will put the slides of Alex and Ed on that, as well as the recording on that. And then I have all your email addresses, whoever has logged in. So I will just send an email out with the link of the box folder to all of you. Okay, good. So yes, thank you for reminding that, and then I have your slides. So let me start with some of the questions here. And all the panelists on the IBM side and the business partner side who are in the panel list, you can unmute yourself. So if I ask a question and if I say, can somebody answer from the panel team, feel free to unmute yourself and then just speak out the answer. So the first question I have is, how big difference is between Seaplex version 12.8 and 12.9? I'm currently using 12.8. Can I expect to get results faster by updating to 12.9? So maybe Ed or Xavier or Ferenc, can one of you answer that?
Definitely. We are, if I can recall, the minimum was, so we have different problem categories, and also we have different sizes of models. We differentiate kind of small, medium, and large. We are release to release, we are focusing on more large models, and we are making progress on those. The minimum is 10% by each release. And as I said, the category are the LP, the MIP, and the quadratic. And also we have now the benders, 2 or maybe even 3 releases before, and we make quite large progresses on those. So the minimum is 10%. Sometimes it goes up to 30% from release to release, depending on the category. So if you have 12.8, it means that basically you are 2 releases away from 12.9 and 12.10 came out afterward. So you have a minimum 20% increase or decrease in performance. But again, if it depends on what category of model type we are talking about, you may have even a 50% or more.
Okay, perfect. Thank you.
This is Xavier Naudet speaking. One thing I would add is that in 12.9, we introduced multi-objective optimization that allows you to specify a hierarchy of objectives, which you want to solve one by one instead of combining everything. That's a big feature that we introduced in version 12.9.
Okay, perfect. Thank you, Xavier. Now, I know we covered multi-objective briefly in the last call, but if anybody is interested or more people are interested, we can bring that topic back in one of the following sessions. One other commonly asked question that I'm seeing, so let me read that before others, because a couple people have asked me this already. So the question is generally about, I guess somebody, Ferenc or Xavier, I think Ferenc, maybe can you go on mute and unmute yourself when you're speaking, or whoever is on unmute. So the question is about examples. So a couple people seem to have asked the same question, that where can they find examples? So one quick answer I will give, that if you're looking for OPL examples, if you have Seaplex already installed, the Seaplex Optimization Studio, or if you don't have it, you can also get the free community edition. It comes with a lot of examples, and I find that as a very good repository of examples. And I know some of you have asked where you can find Python examples. So for that, Xavier has posted the GitHub link on the Q&A box. That's one place where you have a lot of sample Python models are also available on our Watson Studio cloud version. You don't necessarily need an account to access those examples, but if you have an account, I mean, you can also sign up for a free account for Watson Studio and still can see a lot of those examples. And I know the Python examples are not as many as the OPL examples, but we keep adding those examples. But Xavier or Ferenc, if you have, or anybody who knows more about Python examples where people can find beyond what I mentioned.
We package all the examples, Java, C++, C, Python, C, and OPL into the Comment Edition. If you are not a user, you just go there, download the Comment Edition. You have all the examples. You will not be able to solve them because the Comment Edition is 1,000 variable constraints limited. But if you have a genuine commercial version, you will have all these examples, and you have to go to the program files, IBM, ilog, and underneath you have examples, and examples you have OPL and all the Java, C++, and you can have all these what Sumit was talking about. You don't have to go anywhere else. If you already installed the stuff, you will have all the examples, including Python. And if you are not having this installed, you can go download the Comment Edition, you will have all.
And on top of that, I just pushed all my zoo examples into Seaplex a few hours ago, and I just sent the link on GitHub, so you can find that too.
Okay, great. Yeah. And all right, so one more question is, I think this may be again Xavier or Ed or Ferenc, you can take it. What would you recommend when the model's list of active nodes in the branch and bound tree grows too large and consumes large amount of memory, leading to an out of memory?
Well, you go ahead. You are more qualified, I would say.
I'll take this one. So there's two things. You can treat the symptom or you can treat the cause. So the symptom is what you just described, that the active node list is getting too big, causing you to lose memory. But Seaplex has a file parameter setting where you can instruct Seaplex to basically write the nodes to disk. And since Seaplex knows how the nodes are sort of organized, this is much more efficient than relying on a general all-purpose virtual memory manager. So that's the treatment of the symptom. But generally, when that active node is getting so huge that memory like that is an issue, you probably have other performance issues. So you may want to resort to some of the strategies we described in this presentation to get better performance so that the size of the active node list doesn't get as large. And then one thing specifically you can do is set the variable select parameter to 3, which invokes strong branching, which basically generates fewer nodes, but each node has a lot more information. So that's another way to manage node list size. And if that is actually good for performance, that may be a remedy as well.
Okay, thank you, Ed. And so one more question is, again, probably Ed, you would be the right person to answer. I'll just make a quick comment before I give it to you. So the question is, how different, I guess they mean to say, what is the difference between ODH and current default? Oops, hold on. I think the chat just went up, so I lost. Okay. What is the difference between the ODH and current default previous heuristics feature in Seaplex? So I'll make a quick comment saying that deeper question, and we are going to have our business partner, Professor Alkes, and his partner, Robert Ashford, in one of the subsequent calls to talk about ODH. But Ed, do you want to answer maybe in 1 or 2 comments?
I didn't quite catch it. They were asking, what is the difference between ODH and regular Seaplex's heuristics?
Correct.
Yeah, so ODH, I mean, I actually don't know the details of what ODH does, but it is sort of a more elaborate heuristic that is built on top of Seaplex. So you can run it, you know, sort of with Seaplex within your Seaplex application, and it's just it uses existing solutions, and it's just very effective at finding solutions that regular Seaplex as well as all the other solvers can't find. I'm very impressed with it. I use it a lot myself, and at this point, if I have a MIP where performance is bad, and I think that especially when I think the issue is that we're not finding all the solutions out there, I always try it. And occasionally it's actually helpful for improving progress in the best node as well, because what happens is if you get the good solutions earlier, that allows you to cut off and prune nodes much more effectively. So you limit the growth in the active node list, and you get progress that way, even though it really doesn't directly have things to tighten the formulation.
Okay, thank you, Ed. Yeah, and when we have Alkis and Robert on ours as a guest speaker on one of the following calls, we'll go into details of that as well. By the way, I'm reading questions between the Q&A box and the chat box. For future, try to use the Q&A box. I know it's not easy to sometimes find in the multiple windows that WebEx offers, but try to use that because it's easier to track and people can also answer specific questions over there on chat as well. But I'm switching between the chat window and the Q&A, so let me give justice to both of the windows. One question that I had in the Q&A box was, can I build a connection between OPL and R for which the model is built in OPL while the objective function is defined in R? Can anyone answer that? I mean, I have my opinion, but I think let one of the experts answer that correctly.
So it's not just that somebody builds a connector to between the two, but also what kind of solver or what kind of computational thing we are thinking about between or behind the two. If you have to write in R your goal function because OPL cannot, it doesn't provide you enough machinery to model something. To be frank with you, OPL covers Seaplex and CP optimizer, Constraint Programming Optimizer, and CP optimizer's combinatory part can model anything nonlinear, anything what you can imagine, assuming or provided that the variables are integer only or discrete. So if you can model this kind of nonlinearity stuff, what you thought that Seaplex would do, you can do that in OPL. On the other hand, if the R piece is a kind of, it's a goal, but also it ties to some kind of computation, simulation, or I don't know what, then indeed it's an issue. I mean, you have to have the R piece. We are thinking about some kind of black box calling out, where we could incorporate these type of things, but it's not yet in the product.
Okay, thank you, Ferenc. Yeah, and that's what I thought, because since you're modeling the objective function R, I mean, for us, for Simplex, it will be in the current way we do, it will be like a black box. So currently we cannot, but if you can take the model and put it in OPL or Python or basically in Simplex model construct, I think that'll be easier. But maybe in future when we talk about the black box, we'll cover that topic after it's released. Maybe we'll try to figure out if that's possible. But in the current way, not, as Ferenc mentioned. One quick question is, can we have one session on hybrid models? And when they say hybrid model, they meant CP plus MIP models. So yes, we will discuss about that internally and see what we can talk about that. But I think looks like Alex knows about this. Alex, do you want to make a comment about combining CP and MIP models? Is that possible?
Can you hear me?
Yes, we can hear you.
Yes, so it's one of my greatest belief that mixing constraint programming and linear programming, you can really achieve much more. And a long time ago, there was a product sold by iLog. The name of the product was Hybrid. And it was trying to mix constraint programming and linear programming. And it was very complex to use. It was a nightmare to debug. And iLog and stopped this product. And when they stopped, they told me and my colleagues that we were the only guys in the world to really use that. So this was 20 years ago, and too complex. So now, how to hybrid the two, knowing that there is a natural hybrid that is hidden, that is within constraint programming, within scheduling, sometimes when a subproblem is linear, then Seaplex is called. But for you, the user, the easiest way, and that's the way I've used for 10 years, is to use a warm start to hybrid the two. So you have, and that's the example I posted in the log. So you have Seaplex running for 10 seconds, giving a solution. You take this solution and you warm start this solution into CPO. So CPO will work for 10 seconds and will give that solution back to Simplex and again. And that way, you can have very nice results that you would not get by using only linear programming or only constraint programming in a nutshell.
Okay, perfect. Thank you, Alex. And there are a few deeper technical questions for Ed, and I will read that after a few basic questions. But if I'm not able to get your question to all the attendees, feel free to send me an email with those questions, and I can reply you guys back with the answers from the experts. So one other quick question we have is there an open source competitor to Seaplex? So quick answer is, of course, yes. And there are many ones like Pyomo, GLPK, and other team members here know quite other tools as well. One quick comment is, most typically what we see in client conversation is people start with open source, and which is a good thing to do. We also encourage that. As the problem size increases, the performance is not at par. So as soon as the problem size increases, you'll typically see a slowdown of the open source solvers. And that's when most clients come to us and asking for Seaplex. And when they try Seaplex on their existing model, which was built using open source, they do see a significant speed up. So that's my quick comment. The team want to make any comment on open source and any competition to Seaplex in open source?
Right. So open source has two kind of disadvantages. One is that open source math programming, or even if I look at the constraint programming piece, it's not the same as data science, where you know that this is a regression, and then the third year bachelor student can code it in Python, and then it's as good as a commercial one. Math programming has tons of heuristics and certain things what you cannot do in an open source settings. So performance-wise, they are the closest competitor, which is not really kind of commercial and open source at the same time, is kind of 10 times slower if they use Seaplex underneath, because they have their own solver, but also they can plug in some other solvers. So it's kind of bizarre that Seaplex used alone is faster than Seaplex used under them. But everybody else is less than that. I mean, slower. The second thing is that buggy. So again, as I said, we are extremely stable in the past 20 years, I would say. And we, even Gurobi, when they started, the first 2 years, they had problems reporting solutions where it was not the optimal, or maybe it was even violating constraints and so on. So even those guys, they had to have a certain period of time to get a stable code. So and open source again is not a team behind it who knows in and out. So these are the two things, but somebody has to consider. I can give you another thought. We have a big German car manufacturer, and they tried that with an open source stuff, and they are not that bad from modeling point of view. So it was kind of okay. And when they fed to this open source, actually it was CoinOR, if I remember correctly. It was like 2 hours, and when they fed it to Seaplex, it was a few seconds. So they were very surprised, and it was a very quick kill.
Yeah, so I think CoinOR is another one. So the answer, quick question was, are there open source? I think if you're looking for names, it's like Pyomo, this is the Python's optimizer. Then you have GLPK, what I've heard, and then CoinOR, and there are quite a few others. Okay, so I know we are going over time, but again, just we'll continue with the Q&A. So if people are interested to hear the answers, feel free to stick around. We will stick around for another 5-10 minutes, as long as Ed and some of the team members are available. One suggestion here is coming from the audience, is having a session on MIQP would be useful, especially the quadratic constraints management part. So, okay, point taken. We will discuss with the team, and we'll maybe create a session where we cover some of these topics, like deeper topics. And I think there was another such question on similar idea where they wanted a specific topic to be covered. I will go through that. And all right, and one question here is, any comments about IBM Decision Optimization's advantages over Gurobi or local solver? So Ed or Xavier or Ferenc, anybody want to make a few comments about that?
Well, there are two. So the two are two different categories. The local solver is, as the name says, it's local solvers. It's based on certain double search, local search, these kind of things, and they have some trouble, as Ed described how this branch and cut works. We have a mechanism to kind of estimate where you are compared to how good the solution is, what you have already obtained. In local search techniques, anything which is not this kind of based on explicit algorithm, it's very difficult to do that. So from this point of view, we have this advantage over local solve, but it's true that for large problems, the local source technique might be a good, it could give a good first solution. We are, of course, looking at both the techniques and some other based on our deterministic or explicit algorithm, how to improve that. So they are claiming for large models a quick solve, but still it's not enough. On the other hand, the Gurobi side, we have certain modeling pieces, what we have and Gurobi doesn't have. They claim recently, they claimed that they have lots of good stuff for lexicographic, not lexicographic, the piecewise linear. And it seems like a big bang, but if you poke a bit, and I asked directly Gurobi people, so how about the performance? They don't care about that. So you have to be careful on the paper. They may have certain modeling constructs, but if you are not doing the modeling right, you just blow up and things will be very slow.
Well, actually, let me add one thing there. I think one difference is they don't have a constraint programming engine.
Correct. Thank you, Ed, for saying. I was just about to mention that.
Right.
So
The obvious one. Yes.
For scaling problems, if you're doing a MIP approach, we would always recommend try the constraint programming approach. And there are good number of publications from the team here which show how constraint programming can perform better than the MIP approach for some of the scheduling problems. Okay, and then let me read this one last question and then we can wrap up. So it's more of a suggestion. So can you also make an office hours call about the connection to database? Because we had it in 12.6, and then currently we have to do some connection with Java file to the database. So yes, I know this has been a problem, and people have complained about dropping that database connection utility. Parents, do you want to make a quick comment? And then of course we will definitely think about it as a topic in the future session.
Yes.
You want to make a
So
quick
anybody who has this kind of request, yeah, unfortunately we had to drop 12.6.3, the so-called DB link connector, which allowed to connect to database easily. A very short code had to be written, both writing and reading. We got it back, but it's not yet in the product. So send me a mail. We have the code already, so we can give it to you. But again, not in the product. We are trying to see how fast we can put it into in kind of supported way into the product. So send me a mail or Sumit a mail. Whoever is who would like to have this code, not just trying out. It works. It's tested. Now it's, I think, the second or third customers we gave it. But as I said, yeah, we are looking ways how to put it into the product. The last release was in December, and then yeah. So send me the mail. Perfect. And we can share the code, and you can try it out.
Perfect. Okay. And there are a couple questions about Bender's decomposition and cut management. So what I will do is I will take those questions, share it with Ed, and I will respond to the person who asked those, because we are now quite over more than 10 minutes over the call, and I think these can be more technical and detailed questions. But as you guys saw, we are open to discussing questions, competition, anything you feel like. So hope this call was useful, and feel free to join the next sessions. As soon as I arrange the next session, and I plan to do it once every month now on a regular basis, I will post the link on LinkedIn and other places. But if you want to send me an email and say that you want to be invited directly, just let me know. So as soon as I set the call, I will put you in the invitation list directly. I cannot do that without your permission because of the GDPR rules. So I need to have permission from you to say that please invite me directly. In that case, I can now do it. Okay. So with that, I again thank both the speakers and also all the attendees for joining in and asking all these great questions. I think the session worked out good, interactive, and hope you feel the same. So I will close the call, and thank you once again. Stay safe out there, and stay safe, stay healthy. Bye, everyone.
Take care.